This device stores your entire digital life, every photo, every document, every memory you have ever saved.
Seagate ships over 100 million hard drives annually, storing more of the world's data than any other company.
Today, Process Pulse Factory takes you inside the facility where Seagate's most trusted hard drives are born, from magnetic platters and read-write heads.
Sarah has spent 16 years perfecting the environment in which Seagate hard drives are assembled. Not the drives themselves, the air around them.
Sarah thinks about data differently from most people, not as files or folders, but as magnetic domains on.
Her father stores 50 years of family photographs on a hard drive. He does not know it is a Seagate. He does not know how it works.
Shift starts, and somewhere on this floor, a Seagate hard drive that will one day store something.
Before a single Seagate hard drive is assembled, its components have crossed a dozen countries, each one manufactured.
The magnetic platter begins as an aluminum or glass disc, polished to a surface.
The platter's magnetic recording layer is deposited by sputtering, atoms of magnetic material being ejected from a target.
The read-write head is the most complex component in a hard drive, a device smaller than a grain of sand, containing. The voice coil motor positions the read/write head across the disk surface with sub-nanometer positioning accuracy. The hard drive controller IC runs the algorithms that convert user data into the magnetic patterns written to the platter.
Seagate's platter substrate specification requires surface roughness below 0.1 nanometers, a specification that the read-write head we produce for Seagate contains structures at the 10 nanometer scale, fabricated using photolithography.
Seagate designs its own read-write heads, its own magnetic recording media, its own controller ASICs, and its own firmware.
Every Seagate component shipment is a precision logistics event. Platter substrates traveling in nitrogen-purged containers.
Every component delivery at Seagate's facility enters through a receiving process that treats the cleanroom boundary as an absolute.
Seagate's incoming inspection for magnetic platters uses atomic force microscopy, a technique that scans the platter.
Magnetic platters in storage require nitrogen-purged conditions to prevent the oxidation of the magnetic recording layer. Seagate manufactures hard drives across multiple capacity points and form factors simultaneously, including 3.5.
And here, with a magnetic platter whose surface has been polished to atomic smoothness, the production of a Seagate's cleanroom is rated ISO Class 3. The air contains fewer than 35 particles larger than 0.
The final preparation step for a magnetic platter is the application of a perfluoropolyether lubricant, a molecular layer.
The head gimbal assembly joins the read-write head to its suspension, the spring mechanism whose stiffness determines the flying height at which the head operates. A multi-platter hard drive requires a head stack. The vertical alignment of each head relative to its platter must be maintained to within micrometers.
The disk stack assembles multiple platters onto the spindle motor hub, the motor that will spin them at 7,200 RPM continuously for years.
Head disk assembly is the most consequential step in hard drive production, the moment when the heads that cost hundreds of dollars to manufacture are brought.
The neodymium permanent magnets are among the most powerful. The magnetic forces involved in installing them are strong enough to pull.
First spin-up is the moment of truth for every hard drive assembly. The spindle motor accelerates to 7,200 RPM, generating the air bearing.
Sealing the hard drive top cover is the point of no return, the moment when the cleanroom environment inside the drive becomes permanent.
The hard drive PCB carries the controller that makes the mechanical components intelligent. Its spring contact connections are.
Every Seagate hard drive receives its firmware during production, the embedded software that manages servo positioning, data encoding, error correction, and interface protocol. Servo track writing writes the magnetic position reference patterns that the drive's servo system uses to know where the read/write head is at every moment during operation.
Enterprise data center customers specify the acoustic output and vibration characteristics of hard drives, because a drive that.
Every Seagate hard drive undergoes full surface testing. Every sector on every platter written, read, and verified.
From atomic smooth magnetic platters and nanometer scale read-write heads to a fully tested, firmware-loaded Seagate hard drive.
Somewhere behind that door, Valen, Seagate's next recording technology generation is already being developed.
Before going further, we signed a legal agreement. Seagate's recording technology roadmap, the specific areal density targets, and the magnetic recording innovations that will achieve them.
The specific material and geometry innovations that implement those principles in Seagate's next generation are not for public discussion.
Seagate's head disk interface laboratory studies the physics of a mechanical system operating at tolerances that have no...
Heat-assisted magnetic recording heats the magnetic recording layer to near its Curie temperature at the point of writing, briefly reducing its magnetic hardness. Every Seagate hard drive contains a defect map, a record of every location on the platter surface that failed write-read verification during production testing.
The Seagate ST56 in that case stored 5 megabytes, enough for approximately 1,000 text documents.
He said, read after write verification. Every time the drive writes data to the disk, the read element immediately reads back what was just written.
Seagate tests every major competitor hard drive, recording density, sequential and random performance.
Seagate's recording media zones represent decades science research.
Seagate's deployed drive fleet generates smart diagnostic data that Seagate's reliability analytics system analyzes continuously.
We were told this production line qualifies Seagate's heat-assisted magnetic recording drives for volume production, the next generation recording technology. Seagate's overnight reliability testing runs production sample drives through extended read-write stress cycles under elevated temperature.
Seagate uses computational models of the head disk interface to predict how changes in head geometry, media composition,
Writing data to a hard drive magnetizes tiny regions of the recording layer, each region representing a bit.
Manufacturing hard drives at Seagate's production volume, in a clean room environment where a single particle can destroy a drive.
A particle elevation in a hard drive cleanroom is treated as a production emergency. The affected zone is investigated immediately.
The read-write head's flying height, the 3 nanometer gap between head and disk, must be stable to within fractions of a nanometer.
The superparamagnetic limit is the fundamental physics barrier to continued areal density growth, as magnetic recording bits become...
Every head disk contact event, however brief, however gentle, deposits material from the disk surface onto the head.
Seagate's automated test infrastructure processes millions of drives annually, each drive undergoing full surface verification.
In 2020, a cleanroom HVAC component developed a particle-generating failure mode that elevated the particle count in one production zone.
The solution, particle monitoring that reports every 60 seconds from every monitoring point in the cleanroom, with automated alert thresholds.
Every failure mode in Seagate's production history has a detection method and a prevention measure in the current process.
The automated system classified the elevation as a minor event within the threshold that does not trigger an automated hold. Neodymium, the rare earth element in the permanent magnets that drive every hard drive's voice coil motor, is produced primarily in China.
Seagate's helium-filled drives seal the drive enclosure with helium, a gas 7 times less dense than air, reducing the internal turbulence. The cleanroom cannot be paused. The air filtration systems that maintain particle counts below the production threshold must run continuously.
Reliability program. Seagate's reliability program subjects every new drive design to accelerated life testing, temperature cycling.
16 years. That particle count elevation pattern, localized to a moving zone, following a specific path through the cleanroom, has one cause.
Seagate ships over 100 million hard drives annually, storing an aggregate of over 1 exabyte of new storage. Right now, Seagate hard drives worldwide are collectively storing over 1 terabyte of new data every second.
From atomic smooth platters and nanometer scale heads to a fully tested, firmware-loaded Seagate hard drive,
The cloud storage that people use to back up their phones, share photographs, and preserve their digital memories flow lives on.
Security camera systems worldwide record continuously, archiving footage that may contain evidence of criminal activity, accidents, or security incidents.
The genomic data from thousands of patients that oncologists use to personalize cancer treatment. The climate model data.
Seagate's Bloomington facility has been a cornerstone of Minnesota's advanced manufacturing ecosystem for decades.
The Library of Congress, the Internet Archive, The world's major cultural heritage institutions preserve digital copies of human
The complete medical history of a patient, a row, decades of clinical records, imaging studies, laboratory results.
Hard drive areal density has increased by a factor of over 1 million since Seagate's first drive in 1980.
Seagate's cleanroom HVAC systems, which represent the largest energy consumer in hard drive manufacturing, are being
Seagate's Certified Drive Destruction and Recycling Program provides enterprise customers with the security assurance that data.
The energy consumed to store 1 terabyte of data on hard drives has decreased by over 97% in the past 15 years.
Seagate's Mosaic platform brings heat-assisted magnetic recording to volume production, the technology that will extend hard drive.
The hard drive stores what cannot be replaced. The family photographs that exist nowhere else.
Sarah reads particle count trend data the way a meteorologist reads pressure charts, for what the trend suggests about what is approaching.
The cleanroom creates a culture of shared discipline. Everyone in the same suit, everyone following the same movement protocols.
HDA Station 1 has been assembling Seagate heads and disks since 1998 through drive generation.
They met during a contamination investigation in 2015. She was materials analysis, he was cleanroom process, and
He showed her the photograph he was editing, his own wedding photograph from 1975, being digitally restored.
The cleanroom at 2 a.m. in a Minnesota winter is indistinguishable from the cleanroom at 2 p.m. on a summer afternoon.
their head disk assembly yield rate has been the highest in the facility for 6 consecutive years. They say the gowning sequence is the quality system's first checkpoint.
David has been working in Seagate's cleanroom since the drive's capacity was measured in megabytes. He has watched areal density increase by a factor of 1 million.
She walks the cleanroom floor before the day shift arrives because in a cleanroom, the overnight shift's observations are the most.
The areal density milestone was noted in the morning briefing. Then the production schedule continued. The drives being assembled this morning.
In her 5th year, she approved a new gowning material for the cleanroom entry protocol without running the particle generation characterization test.
The particle count tells you that something is wrong. The spatial distribution and temporal pattern of the count elevation tells you what is wrong.
The drives assembled during your shift will store data that someone considers irreplaceable. A family's photographs, a hospital's patient records.
The drive was retested 3 times, 0 defects each time. A platter surface whose magnetic recording layer.
16 years of shifts. She checks the particle counts on the way out, the same way she checks the overnight trends on the way in. Tomorrow at 5:15 a.m., the alarm will go off again.
Liz, you have seen how it is made. Now tell us, what surprised you most about what goes into the drive storing your most important data?
Next on Process Pulse Factory Hemp, we go inside the facility manufacturing something 2 billion people consume every single.
The extended cut, including the full Hamar production qualification line,